students. So today we will discuss one practical topic of our syllabus. So that is how to estimate the COD. So what is COD? So COD means chemical oxygen demand. Okay, so COD means chemical oxygen demand. So it is the amount of oxygen required for oxidation of organic materials. All the organic materials that are whether biodegradable or not biodegradable of any water bodies. Okay, so it is an indicator of how much pollution is there in the water body. It is used to estimate the pollution level of sewage water and industrial wastage fill water body. Okay, so how can we estimate this COD? Okay, so for this estimation, American Public Health Association 2005 has given us a protocol for measuring chemical oxygen demand. Okay, so what are the requirements for estimation of COD? First one, ferrous ammonium sulfate, that is 0.025 normal. Next, ferroin indicator. Next, distilled water. Next, silver sulfate. Next, mercuric sulfate. Next, potassium dichromate. Okay, and one thing you need that COD digester machine. Okay, so these things are needed, and one thing that is 500 ml capacity of conical flask, burette, and pipette. Okay, so these are the requirements for our experiment today. So I am going to rub it off. So one thing I just forgot, that number 11, that is concentrated sulfuric acid. Okay, concentrated sulfuric acid, I just forgot to mention with that. So now, how can we estimate? First, you have to fill the burette with this solution. FAS means ferrous ammonium sulfate of 0.025 normality. Okay. Then take 2 conical fluxes. Okay, these are the conical fluxes. Now take these conical fluxes, this conical flux for our sample water. Okay, for sample water, and this one will be regarded as blank. Okay, this is for blank. Now take 10 ml of sample water in this flux, and in this flux take 10 ml of distilled water. Okay, simultaneously you can run this 2 flux experiment. Okay, next add 1 ml of mercuric sulfate. Then take 5 ml of potassium bichromate. Next take 15 ml of concentrated sulfuric acid. Okay, then these 2 conical fluxes are used to put onto the COD digester machine. You know, the COD digester machine is the machine where the temperature set at the range of between 140 to 150 degrees centigrade. Okay, and these 2 fluxes are kept there for 2 hours. Okay, then after 2 hours these 2 fluxes are taken back and then they are cooled. Okay, then after cooling we have to add here (25 ml) of distilled water. Okay, in this step you have to add in both conical flaskes 25 ml of distilled water. Okay, then we have to put the indicator reagent, that is freon indicator. Okay, in both these two conical flaskes we have to add this indicator. 2 to 5 drops of indicator is enough for addition. Okay, then mix thoroughly all these chemicals very well. Okay, then wait for 5 minutes. Then after 5 minutes you will observe that the color of the mixed chemicals in both two conical flaskes become yellowish green. Okay, then take the conical flaskes against our burette. So this is the burette. Burette, in our previous video we saw that. So this is our burette. So this is our conical flux number 1. Then another burette you can do the titration for conical flux number 2. Okay, then we already put Fs in this burette, and the initial burette reading is taken, and this is final burette reading, and this is difference, and this is mean. Okay, so there are two titrations, one for the sample, another one is for the blank. So we have to repeat 3 times this titration for each sample and the blank sample. Okay, so suppose this table is for our water sample. First initial reading was 10. After the titration the final reading is 15. The difference is 5. Then again our second titration for the sample water is 15 initial, and the final is 20. Then again 5 difference. This is our third titration for the sample. Okay, so these are the differences, and obviously the average will be, the mean reading will be 5. Okay, so likewise we have to do this 3 times titration for the blank also. Blank is the difference, all these chemicals, mixture chemicals are present except the sample water. Sample water where in the blank we use 10 ml of just distilled water, nothing bad. Okay, so our mean reading for the sample water is 5. Okay, we will denote it V2. Okay, then again, if we saw this observation table for the blank, the procedure is same, the titration procedure is same. The one thing is that before we starting our titration, the chemical mixture was yellowish green. Okay, so how can you know your titration is complete or not? You add this FS dropwise when this yellowish green mixed sample is converted into reddish brown color. That will be indicated the end point of the titration, and then note the final reading of the burette. Okay, in both cases the color will be same, sample and blank. Okay, so the blank, similarly we found that from 0. Okay, from 0 initial, 0 was the initial. So final reading was 15. The difference was 15. Then for second observation, second titration, initial was 15. Then final was 30. Again 15 different, and so on for the third titration for the blanks. Okay, and the average is 15. So for the blank, the titration reading, average reading is 15. So I will write V1 for this blank. So V1 is 15. Okay, now note it down. Calculation formula. So calculation formula for COD is COD. The unit of COD is ppm. The formula is V1 minus V2 into normality of FAS into 8 into 1000 all divided by volume of sand. Okay. So V1, you know the V1's mean the mean burette reading for blank titration, and V2 is the mean burette reading for the titration of the sample water you are given. So the V2 titration in the sample titration is also known as back titration. Okay, this is known as also back titration. So V2 is the mean burette reading of your back titration in sample titration. And N means what is the normality of FAS? You know, previously I told you that the ferrous ammonium sulfate has a normality of 0.025. And these are the factors 8 into 1000 divided by volume of sample. So volume of sample we taken 10 ml of water sample was taken. So as per this example, V1 in the blank burette reading was 0.025 into 8 1000 divided by volume of sample 10. So this is 10. So we have to calculate this. So this is the calculation for CO2. So now the water sample given to you contain the chemical oxygen demand of 250. Is the value is desirable for fish culture or not? So according to ICAR, Indian Council for Agriculture Research report, there it is mentioned that for scientific fish culture, the desirable chemical oxygen demand value should be less than 50 ppm. Okay. And your value is 200 ppm. So it is clear that you should conclude that your water sample is not good or suitable for scientific fish culture. Okay. That will create health problems in the aquatic animals. Okay. So hope you understand. You like the video, you understand the video. If you have any question, please let me know. So thank you once again.